We can start now. First of all, good afternoon, everyone. Welcome you all for NTA lecture. So, in the previous lecture, we have completed the M-derived high-pass filter. The theoretical part we have completed, and after that, we have solved one example also based on how to design the M-derived high-pass filter. So, that part we have discussed in the previous lecture. Okay, so these are the three equations we required for the design of M-derived high-pass filter. So for calculating the value of inductor L and calculating the value of C, these two formulas are same compared to constant K type. Only the M formula is required to calculate that value is needed because we are doing the modification in the constant K type so that it will get form M-derived high-pass filter. So M value, it must be greater than 0 and less than 1. That is very important. If your answer is crossing that limit, then formula may wrong or calculation may wrong. Now next, we have seen one table. In that we have compared the formulas of constant K type low pass filter and high pass filter with M-derived low pass filter and high pass filter. LC values formulas are same. Only the value of how to calculate the M for that special equation or special formula will be there. Next, that we have discussed the advantages of M-derived filters over the constant K-type filters. So what are the main advantages? There are the three advantages. First one is we are getting the sharper attenuation characteristics at cutoff frequency. Means instead of getting curve, we are getting the sharper like ideal filter. We can get the characteristics. Second one is the impedance Z0, characteristics impedance Z0. It does not changes. It remains uniform within passband at all frequencies, especially when you are keeping the M value as a 0.6. Next, M-derived filters can be used to construct the composite filters, which will require to design, which will help for any desired characteristics or getting any desired characteristics. For that, you can design the composite filters instead of constant K type. You can use the M-derived filter. So these advantages we have discussed in the previous lecture. So now today we are going to start the next part from this chapter, and that is what attenuators, because the name of the chapter is what? Filters and attenuators. Okay, so in that filters part we have completed up to the previous lecture. Now today we are going to start the attenuator part. So attenuator is very easy compared to filters. So within 3 lectures we can complete it. So I will share now the whiteboard so we can start the attenuator part from today. Okay, so first of all we can discuss the introduction part. So what we are going to learn in this part, that I will tell. So attenuators, under this point we are discussing the introduction part. So in introduction we will discuss about definition of attenuator, then types of attenuators, then after that applications of attenuators. Once we complete the introduction, we will see relationship between Neper and Decibel. So Neper and Decibel both are the units to measure the attenuation. दोन्ही हे युनिट्स आहेत to measure what? Attenuation. So we want to get the relationship between those two units. Third one is types of attenuator. So there are the 3 types for your syllabus. First one is T type attenuator. Then second type is pi type attenuator, and third type is lattice type attenuator. And if we can get the time in the third lecture, we can cover the L type. This is not in syllabus, but we can discuss it if we have time in the last lecture. Okay, so these 5 points we have to discuss in this point under the attenuator. So today we can complete introduction part, then relationship between Neper and Decibel, and then theoretical part of T-type we can cover, and numerical example based on T-type we can cover it later or in the next lecture. So for each type of attenuator, we have to discuss the first theoretical part, and from that we have to get the equations for designing. And once we can get the designing equations, then we can move towards the designing of particular attenuators. Okay, same way what we did for filters. So these are the points. Today we are going to start the introduction part, then relationship between Neper and Decibel, and then T-type attenuator we can start. Now next, we can start with the help of first point. So introduction part, we can start. Anyone know what do you mean by attenuation? Or first of all, you can tell what is the amplification. Amplification म्हणजे काय आणि attenuation म्हणजे काय?
Amplification means it increases the strength of weak signal.
Yes, very good. And what about attenuation?
It reduces the strength and amplitude of signal.
Yes. So it is exactly opposite to that of amplification. So attenuation means what? Attenuation, it is the phenomenon which reduces the strength of signal by certain amount. It may be 0%, it may be 10%, 20%. Are you getting my point? So if it is less than some original value, if it getting reduced, then we can say that the signal is attenuated. Are you getting my point? So attenuation means reducing the strength of the signal. मग strength म्हणजे काय reduce करतो आपण? Frequency reduce करतोय का? नाही. We are reducing what? Amplitude of the signal. We are reducing what? Amplitude of signal. It may be DC signal or AC signal. Okay, we are reducing the amplitude, means we are reducing the strength, and that phenomenon is known as what? Attenuation. So first we can start from the definition of attenuation, and then we can discuss the attenuator. Okay, so attenuation definition we can write here. Attenuation. So it is the phenomenon. It is the phenomenon. It is a phenomenon which reduces. It is the phenomenon which reduces the strength of. It is a phenomenon which reduces the strength of signal. Strength of signal by certain amount. By certain amount. Okay, so that property, that phenomenon is known as what? Attenuation. Now next, from this definition of attenuation, anyone can tell what is the function of attenuator then? If attenuation definition you understood, easily you can tell what is the function of attenuator. So attenuator is what? It is component, it is device, it is circuit. What it is? Yes, anyone? Yes, it is a circuit, or we can say device. Okay, so it is, in our language we can say it is a two-port. It is a two-port resistive network, because only resistors we are using. It is a two-port resistive network which performs attenuation. Which performs an attenuation of signal. So it is a device, or it is a two-port resistive network. It is, you can call it as, it is an electrical circuit, like this, any word you can use. It is a device, it is a electric circuit, or it is two-port resistive network which performs an attenuation. That is very important. So attenuation is what? That is given in above paragraph. Okay, an attenuation of the signal here. So that is known as attenuator. Now next, what are the units of attenuation? There are the two units of attenuation. So already I told in the index part. What are the two units? First one is Neper and second one is decibel. Okay, second one is decibel. So Neper is denoted by capital N, decibel is D, किंवा dB. Okay, so D or dB they are going to use it. Now next one, types of attenuator. So here before that we can discuss here applications. Then we can move towards the types. Applications of attenuator. So what are the applications? So first application in communication system. In communication system, okay, it is used as variable attenuator, means you can change it as is required. In communication system, used as variable attenuator to control volume or audio signal, volume of audio signal. Okay, volume of audio signal in case of, or in we can say radio broadcasting, television broadcasting, radio, TV broadcasting, like this. Attenuator, we can use it. The second application, anyone observed the function generator in laboratory? For testing of circuit or for performing some experiment, for testing circuit or performing experiments, attenuators are used. Attenuators may used, or attenuators can be used. So in the laboratory, how to use? Those are present in function generator. Function generators. So these are the applications, two important applications I want to discuss. One is in the television broadcasting, radio broadcasting, or to control the volume of audio signals, attenuators may be used in FM or previously in amplitude modulation. And in case of a laboratory, in our lab also, there are the function generators. In that, attenuation is there. So if you are pressing 60 dB, 40 dB, that much of amount gets reduced by level. So these two are the important applications they in a daily life we are going to use. Okay. Now next will be the classification. So everyone understood now definitions on all those things, applications. So next we can consider the classification, and then we can start one by one. So here only I will do the classification. Classification or types of attenuator. Okay, so based on the structure, we can classify into four types. First one is T type. Second one is pi type. Third one is L type. And last one is lattice. So in that, this L type is not your syllabus because we are getting the drawbacks. in case of L type, but for other types we are getting good results. So that's why it is eliminated. Now next, this is based on the structure of the circuit. If you want to based on the observation, so based on observation, the types are divided. There are the two types. One is symmetrical, म्हणजे दोन्ही बाजूंनी बघितलं तरी ते symmetrical दिसायला पाहिजे. Symmetrical and asymmetrical. Okay, so in symmetrical, T type is there, pi type is there, and lattice. But asymmetrical in that only L type is there. एका बाजूनेच तो L दिसणार ना, दुसऱ्या बाजूने बघितलं तर उलटा L दिसेल. So we are going to discuss only symmetrical in our syllabus. So this is what the classification of attenuators. So if any questions will be there, you can ask. Otherwise, we can start now the relationship between Neper and Decibel. कोणाला काय questions आहेत? Yes or no?
No, sir.
Okay. So all of the theoretical point you can easily understand. Now next point will be the relationship between the Neper and Decibel. So this question was asked number of times. Explain the relationship between Neper and Decibel. Number of times asked. So that you can mark as a IMP for the offline exam. If the exam is based on the MCQ, then they may ask the MCQ question based on the relationship between Neper and Decibel. So all point of view, this is the very important part. So title will be relationship between Neper and Decibel. So we can discuss it. This is also a theoretical part. So there will be a small derivation is also there, but before starting the derivation, we need to understand what do you mean by Neper, what do you mean by Decibel. We need to understand the definitions. Okay, so first we can try to discuss the definitions and then we can start the derivation. So first point is Neper. So anyone can know whether you heard now Neper. In which chapter you heard about this Neper? Already we have discussed, we have finished that chapter. Yes. Neper frequency, angular frequency. We have discussed it in the chapter number 5, network function, complex frequency, concept of complex frequency. In that Neper frequency and real part is called as Neper frequency, imaginary part is called as what? Angular frequency. That is sigma n. Sigma n is called as Neper frequency. So Neper is, it is defined as, you people are not studying, this shows that you are not doing the study. It is defined as natural logarithm of, it is defined as natural logarithm of input voltage oblique current, voltage or current, any signal you can take, to the output voltage oblique current, provided that network is properly terminated by characteristics impedance Z0. This is the condition compulsory required. So what is the definition of Neper? It is defined as natural logarithm. Okay, that is the log E, log of base E. That is called as natural logarithm. Natural logarithm of ratio is remaining here. Logarithm of ratio of okay, ratio of remaining. So it is defined as natural logarithm of ratio of input voltage oblique current to the output voltage oblique current, provided that network is properly terminated by characteristics impedance Z0. So if I am writing the in terms of equation, so Neper is denoted by N. N is equal to natural logarithm is log of E. So it is the ratio of, we are taking in the mod, ratio of input voltage is V1, because at port 1 we are considering as the input port. At port 2 we are considering as the output port. So input port voltage is V1 divided by output port voltage is V2. So you can also write like this: N is equal to natural logarithm of ratio of input current I1 divided by output current I2. So both are acceptable. So a Neper, next point, a Neper also represented, a Neper also be represented in terms of power, represented in terms of power, in terms of input power P1, input power P1 and output power P2. But what is the relationship between voltage and power or current and power? What are the formulas?
P equal to R.
Yes, P is equal to V square divided by R,
R.
or P is equal to I square into R. आता मला V1 माहिती आहे, V2 माहिती आहे किंवा I1 माहिती आहे. आता इथे V माहिती आहे, मग काय असणार, मला जर इन टर्म्स ऑफ P पाहिजे असेल व्होल्टेज, तर R आपण कॉन्स्टंट घेतो, R remains constant. So in case of what we can say, V is directly proportional to under root of P. म्हणजे V square is directly proportional to P. मग V is directly proportional to under root P. बरोबर आहे. Similarly here, I is directly proportional to P, under root P. बरोबर आहे. मग V is directly proportional to under root P means P raised to 1 by 2. Similarly, I is directly proportional to P raised to 1 by 2. So same, instead of V1 we can replace by P1 raised to 1 by 2. Similarly, I1 you can replace by P1 raised to 1 by 2, like this. So if you are doing, so we can get the N formula in terms of power. So how? Logarithm of base E. So V1 is replaced by, in terms of power, P1 raised to 1 by 2 divided by P2 raised to 1 by 2. Okay, so next it will become what? Log of E, base E, P1 divided by P2 raised to 1 by 2. So this 1 by 2 comes here in front of this. So this mathematical concept everyone knows. So N is equal to 1 by 2 logarithm of base E of ratio of P1 divided by P2. So this is what expressions of Neper in terms of power. Everyone understood now? Yes or no?
Yes, sir.
Okay. Now next one, next definition we can discuss about the decibel. Decibel. So it is defined as 10 times. It is defined as 10 times common logarithm. Common logarithm म्हणजे ज्याचा बेस 10 आहे. So it is defined as 10 times common logarithm of ratio of input power P1 and ratio of input power P1 and output power P2. So if I am writing in terms of equation, so it is decibel is denoted by D. D is equal to 10 times, that is 10 into log of, common logarithm means what? Base 10, that is base 10, ratio of P1 divided by P2. P1 divided by P2 here. Okay, up to this point, everyone understood? Yes or no?
Yes, sir.
Yes or no? Okay.
Yes,
Now,
sir.
this I will give as a equation number 1 here. This is equation number 2. This is I will give equation number 3. Now, P1 is replaced by in terms of voltage or current. So P1 is nothing but what? V square divided by R. So RR will get cancelled. So V1 square divided by V2 square. So that is V1 square, V1 divided by V2 whole square. So that square means 2 raised to 2. So that 2 will come in front here. So 2 into 10 becomes what? 20. Are you getting my point? So D in terms of voltage or current is defined as 20 into log of base 10 V1 divided by V2, or D is equal to 20 into log of base 10 I1 divided by I2. हे कसं आलं कळलं का? So this
Yes,
is my
sir.
equation number 4. This is my equation number 4, and how it gets formed. So for that I will write P1 you can replace by V1 square divided by R. P2 is replaced by V2 square divided by R. So similarly you can do for current. P1 is replaced by I1 square into R, and P2 is equal to I2 square into R. So if you're putting these values here in the equation number 3, so you can get automatically equation number 4. Okay. Now we got the expression of N in terms of voltage, current, and power, as well as we got the expression of decibel in terms of power, voltage, and current, everything. Are you getting my point? So here, these are the definitions we have discussed now. So we will relate the Neper and decibel now. म्हणजे दोन्ही हे एकमेकांना रिलेशन्स कसे आहेत that we are discussing. So before starting the relationship, we have discussed about, first of all, what do you mean by Neper. Then we have discussed about equations, and after that we have completed the decibel. Now with the help of these equations, we can relate the Neper and decibel now. So next part we can continue. I will just write heading. So what will be the condition proper? So that condition I will write, the characteristics impedance remains Z0 only. Okay. Or we can say that the whatever the network we are designing, which known as attenuator, so that network is must be terminated by characteristics impedance. Already we have discussed two-port network. In that we have discussed terminated network. Terminated म्हणजे output port जो आहे तो एक resistor किंवा एक impedance ने connect असायला पाहिजे. It should not be open. It should not be shorted. Okay, it should be connected by Z0. Now for a properly matched network, for a properly matched network by characteristics impedance Z0, consider P1 divided by P2 is equal to I1 divided by I2 square, that is equal to V1 divided by V2 square. Okay, so you can use it, this relation, where V1, you know that already. Once again I will write, where V1 is voltage at port 1, so that is port 1, you can say input port. V2 is what? Voltage at port 2, so that we can consider as output port. Okay, so equation we can consider equation number 3. Equation 4 we can consider equation 4 of the attenuation, that is attenuation in terms of decibel. So what is that 4-number equation? Either you consider in terms of voltage or current, doesn't matter. So D is equal to 20 into log of base 10. I will consider, suppose in terms of voltage, V1 divided by V2. Okay, so 20 into log of base 10, V1 divided by V2. Now, if characteristics impedance Z0 remains constant, then V1 divided by V2 is equal to I1 divided by I2 is equal to N. V1 divided by V2 is equal to I1 divided by I2. Current R is replaced by what? R is replaced by Z0. Okay, so V1 square divided by Z0 divided by V2 square divided by Z0. Z0 cancel होतो. Okay, so this constant is called as what? N. जसं आपण फिल्टर मध्ये कसं घेतलं होतं, L by C is equal to K square. That we have considered, no ratio. So L2 by C1, L1 by C2 is equal to constant K square we have considered. So same way we have considered here the V1 divided by V2. Similarly, I1 divided by I2 consider as a capital N. So N is what? Neper. So put this here. Okay, this we can consider as equation 4. Put this in equation 4. So what we are getting? D is equal to 20 into log of base 10 log of capital N, because V1 divided by V2 is replaced by N here. Okay, so this we got the relationship between what? Decibel and Neper. So N also you can calculate. N is equal to, N कैसे calculate करायचा था? Anyone? 20 कडे गेल्यावर काय होणार? D divided by 20. मग इथं लॉग आहे, N काढायचं असेल तर अँटी लॉग घ्यावा लागेल. So N is equal to anti log of base 10, anti log of what? D divided by 20. बरोबर की नाही? D divided by 20 होणार, मग N काढायचं असेल तर अँटी लॉग घ्यावा लागेल. So these are the two equations we required to solve the numerical examples based on the attenuator part. So these equations will show the relationship between Neper and Decibel. Now one more relationship is there. This is, you can give the equation number 5. So one more relationship is there also in terms of value. So D is equal to 0.115 N. D is equal to 0.115 N. So that is also one relationship we can get in terms of value. So this shows the relationship between Neper and Decibel. The theoretical point, if they are asking, you have to write each and everything. If they are asking in terms of MCQ, you can directly remember the formulas. And these formulas are very important for the design of T-type, pi-type, and lattice type of attenuator. So if any questions will be there, you can ask. Otherwise, we can start the first type of attenuator, that is a T-type attenuator. So take a 30-second and read it each and every point, and we can start now. Any questions? Okay, then we can start the first type of attenuator. So we have to discuss today the theoretical part. What do you mean by T-type attenuator? How to design? Then for designing two equations we requires for the calculating the value of series arm resistance R1 and parallel arm resistance R2. So for that, there will be the derivation. So that derivation we are going to discuss today. So T-type attenuator, we can going to start. So you know that T-type, Pi-type network we are used in the two-port network. We are used in the filter design also. So each filter we have designed with the help of two structures. One is the T-type and another is the Pi-type. So you are aware of that. So first of all, I will draw the diagram so that you can easily understand the structure of T-type. So as already told that attenuator which we are going to learn, that is made up of resistors only. So that's why it is called as resistive two-port network. Okay. So this is about what T-type network. So this is the port 1 dash. You can give the name 1 dash. This is the 2 dash. Okay. Now one more thing I told that this is simple T network, but how to convert simple T network into T-type attenuator? So that we can get by connecting characteristics impedance at the second port. So characteristics impedance Z0. So here, as all network is of resistive, so we can use the Z0 is replaced by R0. Okay. So R0 I will write. R0 is nothing but Z0. So second port must be terminated by a characteristics impedance Z0. So Z0 is in terms of resistor only, and that is named as what? R0. So this is what called as characteristics impedance किंवा characteristics resistance म्हणू शकता. Okay, so this is the diagram of T-type attenuator. T-type attenuator. Now, what are the names? What are the names of these resistors in the series arm? R1, R1, and in the shunt arm, R2 resistor. The shunt arm R2 resistor will be there. Okay, so we can start. This is what the structure of T-type. It is symmetrical. तुम्ही इकडनं पण बघा आणि 2 dash मधून पण बघा. It is looking like same. That's why it is called as symmetrical. Okay, by removing this R0, you can, if you are observing, it looks like same. Okay, from both sides. Now, here already we have discussed the propagation constant, characteristics impedance, phase shift. हे सगळे आपण टर्मिनॉलॉजी बघितलेलं होतं फिल्टरच्या स्टार्टिंग पॉइंटला. Okay, so the above figure or the figure shows the symmetrical attenuator. The figure shows the symmetrical T-type attenuator. The figure shows the symmetrical T-type attenuator consisting of series arm resistance R1, series arm resistance R1, series arm resistor R1, and shunt arm resistance R2. Okay, so it consisting of series arm resistance as R1 and shunt arm resistance as a R2. That is shown in the figure. Now next, the design impedance oblique load impedance oblique characteristics impedance Z0 is equal to R0 connected at output port. Connected at output port of the network. Now we have to determine the formulas for R1 and R2. For that, we are going to discuss the derivation here. Now, next, the values of R1 and R2 can be specified. The values of R1 and R2 can be specified in terms of characteristics impedance R0, and propagation constant gamma, of the network. Okay, so anyone can tell why we are considering the propagation constant gamma here. Characteristics is impedance Z0 is nothing but R0, and propagation constant gamma is equal to alpha. So anyone can tell why we are considering the propagation constant parameter here for the attenuator. आपण हे पॉइंट का घेतोय? Anyone remember what is the definition of propagation constant? It measures what? It measures how much part of signal gets transmitted. Okay, so it measures how much part of the signal gets transmitted. That factor is nothing but propagation constant. So if there is no attenuation of the signal, means 100% the signal is passed. बरोबर है? So if 100% is passed, means attenuation is 0%. If some signal is cutting, if some strength is reducing, then we can say that the signal is attenuated. So attenuation is the factor in case of attenuator. So that attenuation is nothing but propagation constant here. So that's why propagation constant gamma is nothing but alpha here, because alpha is nothing but attenuation. I will write here, alpha is nothing but attenuation, because attenuation characteristics in that alpha, I have used the word frequency versus attenuation. Are you getting my point? So here attenuator we are going to design means alpha factor is very important. So for deciding the attenuation and R0 characteristics impedance, these 2 points, these 2 parameters will help to design the particular attenuator. Particular attenuator म्हणजे काय, T type, pi type, that is like this. In that we have to design the R1, R2 like this. So R1, R2 formulas must depends on attenuation alpha as well as characteristics is impedance R0. So attenuation may depends in terms of Neper or Decibel. Are you getting my point? Attenuation is measured in terms of Neper as well as Decibel. So we know the relationship between them. So attenuation we can measure in terms of Neper. Then R0 characteristics impedance is there. So from these 2 points, we can design the formulas of R1 and R2. Okay, so we can start the derivation now. Equation we can see first of all. So there are the if you are considering okay. So before starting the derivation, we need to mark some current here. So suppose I1 current is flowing through here. इथं तुम्ही एक व्होल्टेज सिग्नल कनेक्ट केलेला आहात किंवा करंट सोर्स कनेक्ट केलेला असाल at the port 1. Then I1 current will flow through this point. Up to this point I1 is flowing. Then the current is getting divided into 2 parts. some current is flowing through series connection of R1 and R0 and remaining current will flow through R2. मग मला काय म्हणायचंय की हा जो करंट आहे मी I2 घेतो. According to two port network, this from second port we are considering the I2 current, no? So I2 current I will mark here. Now next, if I1 current is flowing up to this point and I2 is flowing from this next point, what will be the current flowing through R2?
I1 minus I2.
Yes, so current flowing through R2 is nothing but I1 minus I2. So that all current I will mark here. So according to these currents, I will mark the polarity of voltage drop. This is plus minus here. This is plus minus here. According to this I1 minus I2, this is plus minus here. According to I1 here, this is plus minus here. So I will mark the polarity. Now apply the KVL. Apply the KVL in the loop. या लूप मध्ये तुम्ही KVL अप्लाय करा. Okay, so I will mark here. Apply the KVL here. So write apply KVL, Kirchhoff's voltage law, in loop, which is marked here. So you can start from any point. While applying KVL, we are selecting left hand side bottom point as a first point as well as last point. So go in a clockwise direction. Already polarity marked, current is marked, then value of resistance you know. So we can start here. Sanga mala. Minus to plus is there. That's why plus R2 into I1 minus I2. Resistor into current म्हणजेच voltage ना. Next, come to here. Plus to minus है. Yes, that's why minus. Plus to minus असल्यामुळे minus R1 into I2. Next, come to here. Plus to minus is there. That's why minus R0 into I2 is equal to what? 0. आता हे bracket solve करा. R2 into I1 minus R2 into I2 minus R1 into I2 as it is minus R0 into I2 as it is equal to 0. आता मला I1 टर्म्स वेगळे करायचे आणि I2 टर्म्स वेगळे करायचे. So I1 is only 1 here. So I will keep it in left hand side only. R2 minus R2 into I1 as it is. So this is minus, this is minus, this is minus, each consisting of I2. So take into right hand side. So that will comes R0 into I2 plus R1 into I2 plus R2 into I2. या तिन्ही मधलं काय कॉमन काढू शकता तुम्ही? What you can take common?
I2.
Yes. I2 take common. So I2 कॉमन घेतल्यानंतर काय होणार? R0 plus R1 plus R2. काय केलं मी? फक्त KVL अप्लाय केलं सेकंड रूट मध्ये. करंट मार्क केल्यानंतर पोलॅरिटी मार्क केलं. मग KVL मी अप्लाय केला. So KVL rules you know that. So after applying KVL, I got this equation. This equation I am analyzing now. We are making simpler one. Now R2 into I1 is there in the left hand side. So I want I1 divided by I2 is equal to R0 plus R1 plus R2 as it is in the numerator. This R2 goes to the denominator. Okay. So I1 divided by I2 is equal to R0 plus R1 plus R2 divided by R2. Now, but what I told, I1 divided by I2 is equal to V1 divided by V2 is equal to N. In the previous relationship between, we have used this one. Okay, because characteristic impedance is same. So I1 divided by I2, can I replace by N in above equation?
Yes.
So N is equal to R0 plus R1 plus R2 divided by N R2 divided by R2 here. So this is my first equation now. This is my first equation. Up to this point, everyone understood now?
Yes, sir.
Yes,
Okay.
sir.
So N is equal to R0 plus R1 plus R2 divided by R2. So this equation we require. Now, next point, here only I told. Next point, I will erase this point, each and every point. Or we can Okay. Now I will erase the left hand side part because this is theoretically. Now this T network is in front of you. Can you calculate the input impedance? Input impedance or equivalent impedance observed between port 1 dash. Calculate करू शकता का तुम्ही? What I am telling, characteristics impedance or the equivalent impedance observed between 1 dash. Can you start to calculate? So what I am telling, you have to calculate the characteristics impedance or equivalent impedance R0. Equivalent impedance म्हणूया आपण त्याला equivalent impedance. Can you calculate how the resistors are connected here? The equivalent impedance Z equivalent is equal to R0 can be calculated by R0 is equal to how the resistors are connected, R1 plus R0 that is in parallel with R2 that is in series with R1 like this. Okay, so R1 plus in bracket R2 is in parallel with R1 plus R0. So can you calculate now? This R1 remains as it is. या दोघांचं parallel combination R2 into R1 plus R0 divided by R0 plus R1 plus R2. Up to this point, I understood now. यांचे तिन्हीचे addition होणार ना. Now, from equation 1, what you observed? N is equal to R0 plus R1 plus R2 divided by R2, and that part is available here in this. So can I replace like this? Give the attention here. R1 plus as it is. R2 divided by R0 plus R1 plus R2. That is nothing but 1 upon N. Yes or no?
Yes, sir.
So R2 divided by this term is nothing but 1 upon N. So this I will take from equation 1. From equation 1 we can replace. So left hand side R0 as it is. आता इथं काय करायचं? इथं काय नसतं म्हणजे 1. So you can take cross multiplication. R0 remains as it is here. Right hand side N into R1 plus 1 into this bracket, that is R1 plus R0 as it is. Next divided by 1 into N is N. So again N you can multiply here. Again N you can multiply here. So still we require 5 minutes. So N denominator, it is present in the denominator N. So take into left hand side, multiply with R0. Multiply with R0. What you are getting now? Okay. So here N into R0 is equal to N into R1. Next is what? Plus R1 plus R0. आता मी काय करणार आहे? R1 चे टर्म्स एका साइडला आणि R2 चे एका साइडला ठेवायचे. Okay. So N into R1 plus R1 I will keep in one side. This is next is equal to N R0 minus R0. कारण हा R0 इकडे घेतलं की मायनस होतो. या दोन्ही मधला R1 मी कॉमन काढतो. R1 जर कॉमन काढलं तर N plus 1. ह्याच्यातला R0 कॉमन काढायचा. What is remaining? N minus 1. Now next R1 you have to calculate, कारण आपण फॉर्म्युला कशाचं डिझाइन करतोय? R1 चा. So R1 you can keep in the left hand side. Remaining things you can take in the right hand side. So R0 into n minus 1 as it is divided by this n plus 1. So this is about my equation. Equation तुम्ही 2 म्हणू शकता. This is my equation number 2, which gives the formula of calculating the R1. हा जर फॉर्म्युला तुम्ही यूज केलात तर तुम्हाला R1 चं व्हॅल्यू कॅल्क्युलेट करता येतं. R0 is what? Characteristic impedance. N is what? Attenuation in Neper. So from this you can calculate the R1. आता नेक्स्ट मला R2 चं फॉर्म्युला काढायचंय. I need to find out the formula of R2. मग ते R2 चा फॉर्म्युला कशावरून मिळेल मला? Anyone can tell? How to get? From equation 1, no? इक्वेशन 1 मध्ये तुम्हाला R1 चं व्हॅल्यू रिप्लेस करता येते की नाही? पण इथं R0 आहे, इथं R2 आहे. R1 you can replace, no, in the equation number 1. So we can use like from equation 1, n into R2 is equal to R0 plus R1 plus R2. Okay, so n into R2 plus R0 plus R1 into R2. त्यामध्ये तुम्ही R2 रिप्लेस करू शकता. So R1 you can replace. आता या दोन्ही मधला R2 तुम्ही इथे इकडे घेऊ शकता. n into R2 minus R2 is equal to R0 plus R1 as it is. So R2 you can take common here. R2 into n minus 1 as it is equal to R0 as R1 is replaced by R0 into n divided by n plus 1. Okay, आता तुम्ही कॅल्क्युलेट करा. Now calculate R2 into n minus 1 left hand side as it is. So you can calculate like this. ह्याच्यातलं तुम्ही R0 पण कॉमन काढू शकता. Don't worry. So R0 if you are taking common, what is remaining here? 1 plus n minus 1 divided by n plus 1. असंही तुम्ही करू शकता. So R0 into हे ब्रॅकेट तुम्ही सॉल्व करा. 1 into n plus 1, that is n plus 1. नेक्स्ट इथं काय नसतं म्हणजे 1 नसतं. 1 into this means n minus 1 divided by n plus 1. So ह्याच्यात -1 आणि +1 कॅन्सल होतो. So what is remaining here? R0 into 2n, n plus n म्हणजे 2n divided by n plus 1. आणि इकडे लेफ्ट हँड साइडला काय? R2 into n minus 1 आहे. सो n minus 1 इकडे तुम्ही डिनॉमिनेटरला मल्टिप्लाय करा तर काय होईल आता तुम्हाला R2 चं इक्वेशन मिळेल. सो R2 is equal to R0 into 2n divided by n plus 1 into n minus 1 म्हणजे काय असणार आहे?
n square minus 1 square.
Yes, n square minus 1 square, that is n square minus 1 आपण लिहू शकतो. So this is my second formula. This is my second formula which will help to find out the R2 value. This is my equation number 3. काय कळलं? समजलं का? इक्वेशन 1 घेतलं, इक्वेशन 1 वरनं R2 क्लब केलं आणि R0 plus R1 राहणार राईट हँड साइडला. R0 you can keep as it is. R1 you can replace from equation 2. R1 replace करू शकता तुम्ही. So that you can get. So solve, collect R2 terms in the left hand side. Remaining things all are in right hand side. If you are solving this properly, you can get the equation of R2 here. So these are the two formulas we requires. One is R1 and another is the R2 here. Okay, so today we can stop here. So in the next lecture, we are going to solve the numerical examples which are based on what? T-type attenuator. So how to design the T-type attenuator. They will give the attenuation in terms of decibel. Sometimes they will give the attenuation in terms of Neper directly. कारण आपल्याला फॉर्म्युला मध्ये n लागणार आहे. So n means what? Attenuation in Neper. So if they are giving in terms of decibel, we can convert into Neper. And after Neper, we can use the formulas of R1 and R2 to find out the series arm resistance and parallel arm resistance. Once we get that, we can design the T-type attenuator. So numerical examples we can solve in the next lecture. And today we can stop. If any questions will be there, you can ask. Otherwise, we can stop here. Okay. Thank you then.